Hey guys, how's it going? This is a homework video, and these are just three questions from chapter 9. Questions 15, question 19, and then question 20, part D, as in David. So with question 15, it's called Rolling the Dice Part 1. So consider the population of all rolls of a fair six-sided die. So that is one die. But just to remind you of something we did way back in chapter 6, there is this really cool visual of rolling a pair of dice. So to show you that this is a pair of dice, we said that, well, one die is red or orange and one die is green. Okay, so here's the sample space of rolling a pair of die, right? 36 different outcomes. So, but in number 15, we're going to start off by rolling just one die. Okay, and it's a fair die. So what does that look like when you roll just one die? Well, the different outcomes are, you can get a 1, a 2, a 3, a 4, a 5, or a 6. And how likely is each one of these outcomes to come out? Well, it's just a straight up uniform distribution. Okay, and so the mu and the sigma of this, and they say that just imagine that this is the entire population. This is the population distribution. What's the mu and the sigma of this entire population? So the mu is just 3.5 and the sigma is 1.708. So how did I get 3.5? I just divided, I added 1 plus 2 plus 3 plus, I just added all those up and divided by 6. So that's 3.5. Okay, how did I get sigma? Well, I was a little bit lazy and I didn't want to do sigma by hand because I told you guys you'd never have to do it by hand. So I used my calculator. So I just did a stat edit and I just made one list. And this is different. This is not the actual list, but I just made the list 1, 2, 3, 4, 5, 6. And then I just did a stat calc, one var stat calc, one var stat. And then I did L1 with no frequency list. And it gives me the sigma. Okay. And for that, I used sigma, not SX, because we're assuming that this is the entire population, not that we are sampling from a population. Okay. For part B, it says if you take an SRS of size n equals 2 with replacement from this population, what would you actually be doing? That's the same as rolling a pair of dice. So that's the same as this right here. Okay. And how do I know that that's the same? Because if you roll one die and then you roll another die, okay, or if you roll two die at once, those two die are completely independent. Like whatever you roll on the first die, it's not going to change the outcome of the second die. They're completely independent. Okay. Okay. So part C says list all possible SRSs of size 2 from this population and compute X bar for each one of the samples. Okay, now this is where you have to be a little bit careful because originally what my mind went to was this, like just the outcomes or the sum of the die, but it doesn't ask you about the sum of the die. What it's asking you is like, what are all the different outcomes, and then what is the X bar of each one of these samples, right? So here is what the answer actually looks like. So you can get a 1 1, you can get 1 2 2 1, etc., etc., etc. Then here's the X bar of each one of these samples. Okay, here's the sample mean of each one of these samples. Okay, so it's 1, 1.5, 2, 2.5, 3, 3.5, 4, etc., etc. In part D, it asks you to graph this. Okay, graph the sample means. Okay, so now what are they doing? They're having you sort of graph a sampling distribution, right? And what does it look like? Surprise, surprise, it's unimodal with a mode at 3.5, is perfectly symmetric with a spread of 1.2. Okay, how did I get this mean and standard deviation? That, again, I just used my calculator. Okay, and when we quit that, I use my calculator. I went to stat edit, and I just made two lists. And here are my values. Here's my frequencies. And then I just did a stat calc one var stat with my values and my frequency list. And then I calculated, and then boom, I get 1.22 or something like that. as my sample, as my SX, okay? And so I have a mu of 3.5 and a sigma x. Sorry, I should use sigma because again, we're assuming that this is the entire population because it's the entire sampling distribution. So we get 3.5 and 1.2. Okay. And we described its shape, center, spread, and outliers right here. How do these characteristics compare? Again, when you're comparing two different numbers in statistics, you have to use comparative language. So the same center, okay, of 3.5 and different spreads. And then say specifically like which one is greater than, which one is smaller than. I kind of ran out of paper, I ran out of room, so I didn't do a very thorough job. But what you want to do is write a very thorough job here. You want to say that both of these distributions are centered at 3.5, okay, but the sampling distribution has a smaller spread of 1.2 versus the population distribution spread of 1.7. Okay, so you want to use comparative language and use actual values. Okay. All right, so that covers number 15. The next question was number 19. Okay, so this is number 19, and this is on page 588. Okay, number 19 on page 588. So let me just turn to that. So it says, do you drink the cereal milk? Gross. I used to love cereal milk when I was a kid, but what happens is like, and I don't know if you guys eat cereal. I don't know if a bunch of people still eat cereal or not, but it used to be very popular. Like cereal used to be pushed very heavily in marketing nationally. And a lot of kids grew up eating cereal for breakfast. Like I was one of those kids. But what happens is kids tend to drink, like when you're young, kids tend to drink or eat very, like select very sugary um, cereals. And so what happens is, like, as you're spending time eating the cereal, all that sugar kind of like melts. That's not the right word, but you know what I mean. It kind of like, I can't think of the word, not dilute, not melt, but you know what I mean. It kind of like all that sugar from the cereal like gets into the milk. And so by the time you're finished eating the cereal, you have this bowl full of milk, but it's super sweet, super sugary milk. And if you have colorful cereal like, I don't know, Fruity Pebbles or something like that, they don't make that anymore. But then your milk turns like different colors. Okay. And like as a kid, you think it's awesome, but as an adult, you think, oh, that's so gross. Okay. But, anyways, here's the question. A USA Today poll asked a random sample. So, this is a random sample. It's telling you it's a random sample, and it's telling you that there's 10, 12 US adults, not kids, but adults. So that's our sample size. So I started off by writing down the given information. So our sample size is 10, 12. We know that this is from a random sample. Okay. What they do with the milk in the bowl after they have eaten the cereal. Of the respondents, so this is out of the sample, 67% said that they drink it. So 2/3 of US adults in this sample, okay, 2/3 of these guys said, yes, I drink the milk. So that's our p hat, our sample proportion, right? Now it says, well, suppose that 70% of all US adults, and I added the word all, it says, suppose that 70% of US adults actually drink the milk. So if it says the word all or actually or true, that usually means it's referring to the entire population. So the population proportion, they're telling you straight up, that's 0.70. Okay, let's think about, well, what is capital N? How many US adults are there? I don't know. There's like over 300 million, right? Something like that. There's a lot of US adults. Okay. So, anyways, part A says find the mean and standard deviation of the proportion p hat of the sample who say they drink the cereal milk. That is just straight up our formulas. We know that mu of p hat, mu of the sampling distribution of p hat is just going to be the true population proportion p, which is given to us as 0.7. Sigma of p hat, or sigma of the sampling distribution of p hats, is root pq over n. So 0.7 over 0.7 times 0.3 over 10, 12, which is approximately 0.0144. Okay, B says, what is rule of thumb 1? Rule of thumb 1 is the independence condition. And so since we're sampling without replacement, that is our 10% condition. So we want to make sure that our sample size is not greater than 10% of the entire population. Okay, so we assume that the population of all US adults is greater than 10 times little n, or 10,120. This is reasonable, as the true population proportion is, I don't know, something like 300 million. Okay. Part C. Check that you can use the normal approximate. So what is the normal condition for P when we're chasing a P? The normal condition is that expected successes and expected number of failures are both greater than or equal to 10. Explicitly write that when you're writing your quiz. Okay, write it just like this. Normal condition is NP greater than or equal to 10 and NQ greater than or equal to 10 question mark. Is it? I don't know. Now you explicitly check. So NP is equal to 1012 times 0.7, which is about 708, which is greater than 10, check. Same thing for NQ, check. Okay, so yes, we may proceed. The normal condition has been met. Okay. Part D, find the probability of obtaining a sample of 1012 adults in which 67% or fewer say that they drank the cereal milk. Do you have any doubts about the results of this poll? So this really is a state plan do conclude, but for the purposes of this video and also to save space, paper space, I didn't write out state plan do conclude, but this is just a straight up normal model, right? Because we've met conditions, we've met the independence, and actually in chapter 10, now that I've lectured you on chapter 10, we've met RNI, right? We've met random, normal, and independent. Random, it said it was a random sample. Okay, normal condition is here and independent condition is here. We've met both of those. So yes, we may proceed by using the normal model. Okay. So here's the normal model that we're using, okay? And this normal model has these parameters, 0.7, 0.0144, okay? Because this is the sampling distribution of p-hats from this population of all US adults, okay? Now, right away, I put in these values, which extraneous work. I didn't need to do all that. Really, I needed just these two values to figure out that 0.67 is way over here. Now, right away, like there should be like a red flag going off in your mind, like warning, warning, wait a second. This is more than 2 standard deviations left of the mean. Okay, so that's quite far away from the mean. And it's asking about a left tail. So that is a very small probability. So here is the work, okay, for the probability. And you can see that when we standardize, the z-score is negative 2.0833, so that probability is just about 1.9%. So the probability of getting a p-hat of 0.67 or lower is approximately 0.0186. So yes, we would be wary of this. Okay, I'm going to continue in just a moment. I need to take care of something. Hang on just 1 second. Okay, sorry about that. So then here is part E. So part E is asking about, well, what sample size would you need to reduce the standard deviation of the sample proportion to 1/2 the value you found in A? So I did it the long way. I showed all the work. Well, I know that sigma of p hat is equal to root PQ over N, and we want to get that equal to 0.0072, which is half of what our current standard deviation is. So I just solved this equation for N. So I got N is approximately equal to 4,050, 4050. The other way you could have done it is if you just remember transformations, okay, if we are taking 1/2 of the denominator, so we're multiplying the denominator by 1/2, okay, what are we ending up doing? We're going to multiply this by 4. We're going to quadruple the sample size. So 4 times 1012 is 4048, pretty close to 4050. That's also an acceptable answer without showing all that work. Okay. In part F, it says if the pollsters had surveyed 1012 teenagers instead of adults, what do you think? Would p-hat be greater than, less than, or equal to? And this is not even really a statistics question. This is just kind of like a common sense question. I would guess greater than, because younger people are more likely to enjoy sugar more than adults. Okay. Although 2/3 of adults drank the milk. Wow. Next question is question 20, going to church part 1. And the student only asked about part D. Find the probability that p hat takes a value between 0.37 and 0.43, and will an SRS of size n equals 1785 usually give a result p hat within plus or minus 3 percentage points of the true population proportion? Explain. Okay. And so you've done a bunch of work in A, B, and C to kind of set up part D. So I'm not going to show the entire state plan do conclude, because that's kind of covered in A, B, and C. So here's just the probability statement. Hey, what's the probability that p hat is between 0.37 and 0.43? Well, standardizing, that's the same as z being between negative 2.59 and 2.59. And if you think about just like the standard normal, and just think about like the empirical rule, 68, 95, 99.7, 2.59 to negative 2.5, that's an extremely wide interval. So what is that probability on your calculator? Okay, on your calculator, again, what you're going to do is just do second distribution, go normal CDF, and you can see I still have it in there. Negative 2.59 is my lower bound. My upper bound is 2.59. This is from the Z's, or from the standard normal, so 0, 1. Go ahead and paste that sucker and press enter, and you get, wow, 99%, greater than 99%, 0.9904. That means that over 99% of all samples of size n equals 1785 will produce a p hat within plus or minus 3 percentage points, 0.03, of the true population proportion p. Okay, so that's an extremely wide interval, so it's extremely likely. Okay, that's all we have. Look for the next video where I'm going to go over some of the other homework questions. Thank you to all the students who asked those questions, and I'll see you in the next video. Don't forget to press like, press subscribe, and press on the bell notification button. Bye.